Good day, everyone. Thank you very much. As I promised, I will record this session. This session is not much, so then 2 or 3 slides. Like I promised, this is part of this week class, which we were unable to cover during the class because of time. So I will quickly go over this. So triacylglycerol, which we already explained as simple lipids, as fat and oil. What are triacylglycerol? As we earlier explained, they are an ester of fatty acids and alcohol. You have a fatty acid and alcohol, which is glycerol. This triacylglycerol exists widely in plant and animal in form of fat and oil. And we say they exist as fat or oil in a room temperature. This all depend on quite a number of factors. One of the factors majorly is the saturation level of the fatty acids. When the fatty acids are unsaturated, the packing of the fatty acids is very difficult. Therefore, there is the likelihood that this fatty acid can easily exist in form of lipids, because the more the unsaturation level, the more the ability of it not to pack together. So the more the flexibility, just as we are explaining the flexibility and fluidity of cell membrane. So the more the unsaturation level, the more the fluidity, and the more the tendency it will become oil or liquid in room temperature. And that also can be linked to the carbon chain, the short fatty acids and the long fatty acid chain. The short fatty acid can have a higher chance of becoming liquid at room temperature than the very long chain fatty acids. So triacylglycerols usually form the primary source of energy in animals. So animals store triacylglycerol for reservation of energy. Triacylglycerol is stored in specialized form of tissue called adipose tissue. And this adipose tissue, like I earlier explained, that they are predominantly found in subcutaneous layer of the skin or around the abdominal cavity. Why does the body decide to store energy in form of triacylglycerols? Because the triacylglycerols are more efficient in storing energy. For example, here I give an example that 1 gram of fatty acid can be oxidized to produce 9 kilocalories of energy. One equivalent amount of 1 gram. One equivalent amount of protein or carbohydrate can only yield 4 kilocalories of energy. So instead, why will the body store 1 gram of substance, and at the end, when oxidizing that substance produce less energy? Rather, the body will likely prepare to store a small amount of substance, and when oxidized, that substance will produce high amount of energy. That is why the triacylglycerol is being stored in adipose tissue for the synthesis of for energy storage. So triacylglycerol are usually hydrolyzed, can be hydrolyzed to form monoacylglycerol, diacylglycerol, glycerol, and a combination of glycerol and a fatty acid. Okay. Now by structure, I already explained the structure. We said the triacylglycerol contain a fatty acid and a glycerol. So the fatty acids form an ester. We talked about esterification reaction and the formation of ester or esterification reaction at carbon 1, carbon 2, and carbon 3. When formed at carbon 1, it is monoacyl, diacyl, 1, 2 of them, while when the 3 of them form a triacylglycerol, which we have earlier explained. And we say they can also undergo hydrolysis, usually by lipases like pancreatic lipases, where it's hydrolyzed this in the presence of water to produce the monoacyl, diacyl, and the free fatty acids. Fat and oil. Oh, I'm supposed to put the picture of fat, the one that exists in solid, but you all know fats that exist in liquid and the fat that exists in form of solid at room temperature. We have been using it for cooking, and usually the fat that exists in form of in form of solid is the one that usually when you slaughter animals, the oil, the part that is obtained from oil, usually at room temperature, when you keep it, it becomes solid. So that is the fact. So we talked about the, before then, we'll also say that these fatty acids can be, or triacylglycerol can be classified into the simple triacylglycerol. They are called simple when all the three fatty acids are the same. But when all the three fatty acids can be different, that type is called mixed triacylglycerol. And remember also, the fatty acid can also be saturated, and it can also be unsaturated. So, okay, before that. So I will talk about the properties of triacylglycerol, like 102. One of the properties is hydrolysis, which I earlier mentioned, that it can undergo hydrolytic reaction by most especially enzymes like liphases to produce diacylglycerol, monoacylglycerol, fatty acid, and glycerols. And it can also undergo saponification reaction in the process of soap formation. Those people that produce soap, soap, the one we use in washing our clothes and bathing. And some of this TAG were used, or some of these fatty acids undergo esterification reaction, for example, with sodium hydroxide to form a sodium hydroxide esters. Sorry, it's forming sodium esters, and these sodium esters are the normal soaps we use for washing. And it can also undergo a process we call rancidity, or an oil can be rancid, which is basically the spoilage of an oil. How do you know that a particular oil has spoiled? You know that a particular oil is spoiled maybe due to some unpleasant smelling, or the test from the test, you will understand that it has spoiled. What actually happens usually is the deterioration. And how does the deterioration occur? Usually it could be due to oxidation, maybe by microorganisms, exposure to air. Air contains oxygen, so you can easily oxidize this fatty acid, most especially when you have this double unsaturated fatty acids. So the unsaturated fatty acids can easily be the level of the area of the unsaturation where you have the double bond. I already explained that where you have a double bond, you have a very rich electron. So you can have a high electrophilic attack by oxygen, and that can lead to formation of quite a number of products like decarboxylic acid, aldehyde, ketones, and these are the ones that produce this odor, this unpleasant smelling, and the changing of the taste of oil. So this is basically what we need to talk about with regard to fat and oil. If you have any question, please ask your question under the comment, and then any clarification, you also know how to meet me. Thank you very much.